many scientists are convinced that there's a real threat of what you could call a methane bomb or a methane outbreak of very large magnitude, sufficient to perhaps cause an immediate warming of at least 1 degree. So this is one of the many threats, but certainly one that we ought to be facing up to.
Welcome and thank you for coming to our panel discussion today on methane emissions. I'm Dale Walkenin, the executive producer of FacingFuture.tv. Here at the COP, 100 nations just signed a global pledge to cut methane emissions 30% below 2020 levels by 2030. Many will argue that this is not sufficient, but it is a recognition of the serious threat we face. Today we have 3 experts who will help us understand the threat and the possibilities for mitigation. Peter Fakowski is an MIT-educated physicist, entrepreneur, and philanthropist with over 27 patents. He's the founder of Methane Action, the Foundation for Climate Restoration, the Methane Oxidation Corporation, and most recently the Stable Planet Alliance, which is working to restore a sustainable population. Daphne Weisham is the Chief Executive Officer of Methane Action and a fellow at the Center for Sustainable Economy. She helped pioneer a new policy that is forcing polluters to pay for the risks which are now externalized on frontline communities. Daphne founded and directed the Climate Justice Program at the Institute for Policy Studies in Washington, D.C. Peter Wadhams is Emeritus Professor and head of the Polar Ocean Physics Group at Cambridge University. He is one of the world's leading experts on methane, having led over 50 polar expeditions. His widely read book, A Farewell to Ice, warned that melting permafrost could soon release massive bursts of methane into the atmosphere. Peter, you've been studying the Siberian coast of the Arctic Ocean, where the permafrost is melting above the shallow seabed. Can you tell us what's happening there now?
This is amongst the many methane release processes which are going on, both from animals and from machinery, that is leaks from pipelines. There's one concentrated source which is thought to be offer an immediate threat, and that's that under the seabed of the East Siberian Sea and other coastal seas of Siberia, that is Kara, Laptev and Barents, there are thick sediments made of methane combined with water to form a solid substance called methane hydrates. Every year a Russian group went to the Siberian Sea and saw an increase in quantities of bubble plumes coming out of the seabed. There was Natalia Shakova and Igor Samoletov. And the quantity of methane being released each year got greater and greater. And what it looks like is that the methane hydrates are protected from disintegration by a thick layer of permafrost that lies on top of them. And this layer of permafrost acts like the lid on a pressure cooker, which keeps the methane hydrate stable. But as soon as you release that pressure cooker, as soon as that layer of permafrost melts, then the methane is released as a gas. So there's a tremendous threat of a massive gas release. And that threat is quite likely to be realized because the layer of permafrost is melting since the sea ice has retreated from that part of the Arctic or the coastal seas and giving you quite warm temperatures in the summer, up to 11 degrees. And that means that each summer, some of that permafrost melts, the layer gets thinner, gets broken up, and the pressure from below for the release of methane gets greater and greater. So Natalia analysed this and is convinced, and many other scientists are, that there's a real threat of what you could call a methane bomb or a methane outbreak of very large magnitude, sufficient to perhaps cause an immediate warming of at least 1 degree. So this is one of the many threats, but certainly one that we ought to be facing up to and trying to find ways to get rid of that methane.
Thank you, Peter. Unlike CO2, we can't sequester methane. Some technologies are in the early stages to deal with it once it's released. But by far, our best bet is to try to keep it out of the atmosphere to begin with. The US EPA states that when livestock and manure emissions are combined, the agriculture sector is the largest source of methane emission in the United States. Daphne, do you think we can limit meat and dairy in our culture to buy us some time to prevent the overwhelming methane release that Peter has just outlined?
Well, as you've noted, agricultural sources of methane are, in fact, the largest source of methane globally. Fossil fuel emissions are the number 2. But the problem is that we are currently seeing methane levels rising from other natural or biogenic sources. As Peter outlined, permafrost is one source, and wetlands is another. So we face a challenging task of both limiting anthropogenic emissions as much as possible, and one way is changing diet, certainly. Another way is being proposed by the U.S. Department of Agriculture to provide financing to help limit the methane releases with biogas digesters and that sort of thing. That's been proposed at the COP here. Methane Action, the group that I direct, we are proposing, in addition to limiting methane emissions from anthropogenic sources in excess of what has been proposed here at the COP, namely 30% below 2020 levels by 2030, we are suggesting, as is the UN, that we need to go further and cut anthropogenic methane emissions by 45%, and an additional 50% over and above what has been pledged here by 2030, just to keep 1.5 degrees Celsius as an upper limit. But we go further than that and call for an emergency investment in methane removal technologies. The scientists that I'm working with from Cambridge, Stanford, University of Copenhagen, and elsewhere are on the cusp of some very exciting ways in which we can enhance the atmospheric oxidation of methane. Methane is oxidized naturally in the atmosphere, and there are ways of enhancing this that are very promising, but right now they have no funding. So we are urging that governments globally invest in methane removal to avoid the kind of crisis that Peter has pointed to, the potential for methane burst, as well as to allow us to meet and exceed our Paris targets. If we invest in methane removal now, we have the potential to roll back climate forcing by over 15 years. This is a huge potential game changer. So we need to ensure that the scientists have the resources they need to advance the technology, and then scale up the governance and oversight to make sure that it is used wisely and well.
Thank you, Daphne. Peter, you also work closely with Daphne, and your project, the Climate Restoration Project, can you tell us what that's about and how that can help us prevent the methane release or the technologies of taking it out of the atmosphere?
Yeah, thank you. Peter really described one aspect of the climate problem, which is the threat of a burst of methane from the Arctic, which last time that happened, which was the last time the Earth lost its polar ice cap, was an extinction event, which of course we want to avoid. And as I and my colleagues have been developing climate restoration, then we're discovering that it's actually achievable. So climate restoration is defined as returning greenhouse gas levels, CO2 and methane, back to levels that humans have survived long term. So we all want our race to survive, and getting the conditions back to that is what we really want. Of course, the current goals of net zero emission will leave us at 460 parts per million of CO2, 50% higher than humans have ever survived before. And of course, no scientists have ever predicted that we have more than a slight chance of survival. So climate restoration establishes that goal that we actually do want scientifically to survive. And one of the key solutions Daphne pointed to is I started working with Professor Wadhams several years ago when we heard about the massive bubbling from the Arctic. And the question is, what can we do about that? And it turns out that scaling up natural repair, natural elimination of methane is very viable. And Daphne mentioned that. We've established a company called the Methane Oxidation Corporation, which is developing the technology to multiply nature's oxidation by a factor of 2, and that would actually reduce methane levels by a factor of 2 and bring global warming just from that back to what it was about the turn of the century 20 years ago. It turns out that CO2 removal is also at that kind of scale is beginning to do very well. Most of us are aware of the fact that our planet has gone through ice ages every 100,000 years for 1 million years. And every time an ice age happens, nature removes that trillion tons of CO2 that we need to remove. And if we use nature's method, it becomes very viable. So climate restoration is defined as getting CO2 below 300 parts per million and doing that by the year 2050, which actually gives us time to do it before the possibility of the disintegration of our climate system, our ecosystems, our political systems, and even our social systems. We can see a lot of decay, and we may not have more than that 30 years. And so in this COP, there's becoming a lot of interest in really raising the bar on climate so that we commit to restoring the climate for our children.
Thank you, Peter. Peter Wadhams, I have two Peters here. You were telling me that methane is a highly reactive substance and that chemically we might be able to, if we had the funding and the will to find ways to deal with methane before it becomes a serious problem in the atmosphere. Do you want to say some things about that?
Yes, well, methane is much more reactive than carbon dioxide, and carbon dioxide, when you release it into the atmosphere, what you release stays in the atmosphere for some thought hundreds of years, and others think thousands of years. So we're still breathing carbon dioxide that was generated in the Industrial Revolution. But you can't get rid of carbon dioxide easily because of that. But methane, if you release that into the atmosphere, is gone in about 10 years, and that's because it's oxidized as soon as it comes in contact with the air, and it turns into actually carbon dioxide and water vapor, so it becomes a less vicious greenhouse gas when it oxidizes. So you can get rid of methane either just by leaving it to oxidize by itself, or by burning it off, flaring it if it's coming out of a pipe. But all of these are longer-term measures. You can get rid of the methane by those methods and by other chemical methods that have been developed. But while it's still there, it's very much more potent than carbon dioxide. It's maybe 100 times as powerful per molecule. So a methane release will give you a very, very severe climatic impact for a period of years, whereas carbon dioxide release gives you a less severe impact over a much longer period.
We had talked also about iron salts as a promising technology. Peter Fakowski, I think, could you tell us something about that?
Yes. Nature has two different pathways for oxidizing the methane. And as Peter said, the methane in our atmosphere has a half-life of about 8 years, and we want to reduce it by a factor of 2. Iron chloride is an iron salt, is a naturally occurring compound, and the iron in nature will often come from dust such as the red dust of the Sahara. It's red because of the iron. And it'll get chlorine from the salt over the ocean. And by increasing the amount of that, by basically producing iron chloride and putting it into the atmosphere there's very strong evidence, both theoretical and experimental, that we can oxidize, we can get the methane level back to what pre-industrial in 5 years.
That does sound encouraging. Daphne, would you like to weigh in on this?
There are a number of potential technologies that methane action is looking at, one of which is the iron salt aerosol. We are agnostic about which approach is best to be pursued until we do an independent environmental impact assessment and make sure that we have safety assured and make sure that we have engagement of affected communities. But iron salt aerosol is one approach. Another is called solar chimneys, which is a way of potentially photocatalytically breaking down methane into CO2 and water. Another that Stanford professor Rob Jackson is working on involves zeolites that could be paired with direct air capture machines and act as sort of a sieve, catalyzing again a reaction that breaks down methane into CO2 and water. There are also methanogens that can be applied to, for example, landfills that can naturally decompose methane before it reaches the atmosphere.
We're going to have sort of an open discussion here, so anybody can weigh in at any point. So would anyone of you like to say something else?
What's happening at the moment is clearly the need for getting rid of methane is the fact that its concentration in the atmosphere is growing relatively faster than that of carbon dioxide. So from carbon dioxide being the dominant greenhouse gas and methane following a long, long way behind, methane is now beginning to catch up, and that's something we should be concerned about because of the many sources of methane there are, like animal processes and leaks from gas pipelines. Each of them is contributing seemingly more than it used to be. So somehow we've got to find out which are becoming the dominant methane sources, and therefore which are the ones that we must try to get rid of with greatest urgency.
I think we've created some methane release in the oceans by fish farming and farming fish on land because when the manure from the fish sinks into the sea, if it's shallow enough, I believe that releases methane.
Well, there are, of course, many processes, such as fish, of course, cattle, almost any kind of agriculture produces methane. And the concern that I think we all have is resolving the climate crisis, restoring the climate. And it turns out that from the work that I've done, doing the methane oxidation is going to be by far the fastest and lowest cost way to restore methane levels. Of course, we're going to need to do everything we can to reduce methane emissions. But the design of methane oxidation is that in the case that a methane burst comes out of the Arctic, and of course there's good evidence that a methane burst is starting, the way that we can deal with a burst or anything smaller is by oxidizing it rapidly. So by doubling the rate of oxidation, we can ensure that a burst lasts only half as long, is only half as intense. And that means that rather than being an extinction event for our species and other species, it'll be a disturbance, but one that we can survive.
CH4, 4 hydrogen molecules, is that something that we could chemically work with and possibly utilize in hydrogen technologies going forward?
Methane is often used to produce hydrogen gas. But it's been assumed to be a short-term solution, and I think that's really the basic answer to you, is that if you're mining methane from your fossil fuel, obviously you're using the fossil fuel. It's a rather inefficient process, and the hope is that it'll be replaced by some clean process, perhaps powered by solar energy. At the moment, most experts are not optimistic about that. It's a good possibility that will work. So there's debate about whether methane is a bridge to hydrogen, and whether hydrogen is even a bridge to clean energy altogether. There's a good chance it is, and there's a good chance it's not.
Are there questions before we come to our closing?
Hi, I'm trying to understand the basics of the time that we have in the Arctic, given that the Arctic is warming up 3 times as fast as the rest of the planet, and the thickness of the ice that's covering the methane on the Arctic shores, and the fact that there is some methane release, I assume, through cracks in that ice. How long do we have before there will be a very large methane release?
Well, perhaps I can answer that really by reference to a colleague who is here, Stephen Salter, who's developed a technique for cooling the climate, and it can be applied especially to the Arctic. And if we're wondering about methane release in relation to ice in the Arctic, the ice is certainly disappearing, but if there were a way of bringing it back, refreezing the Arctic, that would take care of the problem of the methane coming out because of warming of the offshore water. And the technique that Stephen's developed is to release a fine spray of water particles through nozzles, and that brightens up clouds, and that means they reflect more radiation. So in that sense, if you can cool a region of the Earth, like the Arctic Ocean, by that means, and bring back sea ice, then you won't get this cycle of the ice melting and the warmer water allowing methane to come out. You're stopping the methane at source.
So from my perspective, from climate restoration, we've sort of missed the bus because the bubbles are coming out and 95% of the Arctic ice has already left us. And so then the question is, if the methane burst happens, can we survive? And the answer looks like yes. And that's what we want to focus on, is take the likely future, which is things will continue getting warm, and then let's deal with it.
Okay. A quick question.
Yes, methane liquefies at minus 160 degrees, and I did do some calculations about taking methane from a cowshed and cooling it and liquefying it and removing it and then warming up the rest of the air. The calculations didn't really look completely compellingly attractive at the time, but maybe I was guessing things wrong, and I wonder if improvements in heat transfer for heat pumps might give us a way to recover methane from carb reduction at least.
I was going to say as a physicist, but most of us, a number of us here are physicists. It's an interesting approach to dealing with methane from sources such as cattle. And again, my calculations are that by the time you do that, and there's a lot of cattle on a lot of countries and a lot of continents, that having a simple, not simple, but a unified methane oxidation deals with that once, in a certain sense, once for the planet. And that's really critical. And I'm very optimistic, especially after President Biden's speech a couple days ago, taking on methane as a goal of reducing methane 30%. I think we can get the support to grow this rapidly and deal with methane within the decade. Even methane from a burst or from cattle.
Well, certainly if we stop eating the cattle, it would improve matters. I think there was one more question, and then we're out of time.
So question about the line shape that we expect for such a burst. What's our best estimate of the time scale of which this will happen?
The time scale, I think.
Well, the question, yeah, was the original question there about when, if this burst comes about, how long will it take? The Russian scientists are sort of thinking it will be quite quick because the water temperature in the summer is now getting quite high. I mean, I've measured 11 degrees in which this is in water that used to be frozen year-round. So that amount of heat coming out of this sea every summer for 4 or 5 months a year is producing a lot of melt rate for this protective layer of permafrost, which everybody's depending on to save us from a methane outbreak. So my personal feeling is we're at risk now, and we'll certainly be at greater risk within very few years. So we better get ourselves sorted out about what we're going to do about it.
I wish we had more time. This has been a wonderful panel. It's been very informative, and we thank all of you for coming and participating in our discussion today. Thank you.